This topic presents the addition rule as a method of finding probabilities that can be expressed as the probability of A or B. The probability that either event A, event B, or events A and B both occur as the single outcome of a procedure. So the key word here is or. When you see the word or, think addition. However, there are two different parts to the addition rule. So we have a definition. A compound event is an event combining two or more simple events. The formal addition rule, when finding the probability that event A occurs or event B occurs, find the total number of ways A can occur and the number of ways B can occur, but find that total in such a way that no outcome is counted more than once. Then divide that total by the number of possible outcomes. So, our tool that we're going to be using for OR is we find the probability of A, add it to the probability of B, but then subtract where they overlap. Where do A and B occur together, if at all? And that's the question that we have to ask ourselves when doing these problems. Can A and B occur together? So that's the warning that I was just discussing with you. Can A and B occur together? You need to ask yourself that. Make sure that you decide yes or no and use the appropriate formula. Because if A and B do not occur together, we can get away with just adding the probability of A to the probability of B and being done. And that's the case because the probability of A and B occurring together would be 0. And if you subtract 0 from something, it's just that something, correct? So, events A and B are disjoint, or what we call mutually exclusive, if they cannot occur at the same time. Then we can modify the addition rule to the one you see currently on the screen. Examples. If one card is randomly selected from a deck of cards, what is the probability of selecting a king or a queen? So, probability of king or queen, when you see that word or, just go ahead and put a plus sign in there because we know we're going to have to add something together. So, the probability of king is 4 over 52. The probability of a queen is 4 over 52. Can you select a king and queen at the same time if you're only selecting one card? The answer to that question is no. Therefore, we can just add these together. That's 8 over 52. And reduce that to 2/13. On the next one, you roll a single six-sided die. Find the probability of rolling an even number or a 3. Again, since we have that keyword or, we're going to have to add something together. Find the probability of an even number. Single six-sided die. Your sample space of the numbers 1 through 6. The ones that are even are 2, 4, and 6. So there are 3 of them out of 6. How many ways are there to select a 3? Just one, because there's only one 3. So 1/6 for the probability of 3. Now, can you roll an even number and a 3 at the same time? No, because 3 is odd. So we don't have to subtract anything on this one either. Adding those together, we get 4/6 or 2/3. If one card is randomly selected from a deck of cards, what is the probability of selecting a king or a heart? So, the probability of king or heart. Or, keep being the key word, we're going to have to add. Probability of king is 4 over 52. probability of a heart, there's 13 hearts out of 52. Now we ask ourselves, do we need to subtract anything? Can these two occur together? The answer is yes. There is one card that is a king of hearts. So we subtract 1 over 52. And that's 16 over 52. Or 4/13. Next example, the table below describes the smoking habits of a group of asthma sufferers. First question, if a person is randomly selected from the 941 subjects, find the probability of selecting a woman or a light smoker. So the probability of woman or light smoker. Again, keyword is or, so we know we're going to have to add. We may or may not have to subtract something. Let's look at, here's our women, and here's our light smokers. So, probability of women, it's totaled for you, that's 459 out of 941. And then, probability of a light smoker, again, that's totaled for you, so 79 out of 941. And we see that we have a place where they overlap. So they can occur together. You can have a woman that's also a light smoker. So we have to subtract that, 45 over 941. And once we do that calculation, go ahead and convert that to a decimal with 3 decimal places. That would be 0.524. Now in the next problem, we're going to be looking for heavy smokers that are also men. So let me erase our circles for our women who were light smokers. So, number of men, number of heavy smokers. We see they overlap, so we're going to have to do another subtraction. So the probability of heavy smokers or men, probability of heavy smokers, 78, because there's a total of 78 heavy smokers over 941. Add the probability that you select a man, so there's a total of 482 over 941. Subtract where they occur together, and that's 31 over 941. Those are the men that are also heavy smokers. And again, round that to a decimal with 3 decimal places to get an answer of 0.562.